Well, alright then.
Hello there. You know, I'm sure you can relate that wealth can be an awful burden at times. I just don't know what to do with my money. And so I try and I try, but I just can't think of ways to spend it. Come, Gustavus. Thank you, thank you. Well, I'll be burning a couple of Washingtons today. Well, thank you for joining me.
Just got paid and I got a little money to burn.
Wow, how did that happen? We will explain how vapor pressure and specific heat can affect the combustion of the bill and allow it not to burn even though it was lit on fire. Go Wings!
Okay. A combustion reaction occurs between alcohol and oxygen, producing carbon dioxide and water and energy. And this is an exothermic reaction, so the energy goes to the product.
Okay. So the specific heat is the amount of heat per unit mass required to raise the temperature by 1 degree Celsius. The specific heat of water is 1 calorie per gram times Celsius. Equals 4.186 joules per gram times Celsius. And that's higher than any other common substance. That means that you have to input more heat into a mole of water to make it boil or to raise its energy than most other common substances, and therefore the isopropyl alcohol that we used had a lower specific heat and was therefore easier to raise the energy thereof, and that's why it burned instead of water.
Vapor pressure is an indication of a liquid's evaporation rate. It relates to the tendency of particles to escape from the liquid. Isopropyl alcohol has a vapor pressure of 44 millimeters of mercury at 25 degrees Celsius, while water has a vapor pressure of 24 millimeters of mercury at 25 degrees Celsius. Because isopropyl alcohol has a higher vapor pressure than water, it is more volatile and it burns before the water or the bill.
Basically, the isopropyl alcohol burns at a lower temperature than the water. That's why you can set your money on fire without it actually turning into ashes.
You getting it? Ode to the brave Washingtons that put their lives on the line so that we could conduct this great experiment.
Okay, God.